gram stone is thrown vertically upward with an initial velocity of 10 meters per second from a starting point of 1.2 meters above the ground. Here's our drawing. So, we need to find the potential energy in different situations, and then we go with Jihe so that she can explain the problem.
So, what is the potential energy of the stone's maximum height relative to the ground? To know this question, we have to find the data, which is mass 200 grams, initial velocity 10, the height is 12 meters, and we have to find the potential energy. To find the potential energy, we first need to find the correct units. So we have to convert grams into kilograms. So 200 grams divided by 100 is 0.2 kilograms.
Okay. So after that we have our data list here. We're gonna look for the value of y, that it's it's gonna be the height that the rock is gonna reach. So for this we need the formula for y, so it's going to be final velocity squared minus initial velocity squared over 2 times gravity. So here we substituted all the variables for the values we have in our data list here. Okay, but this is not the final value for y. For this we need to add the 1.2 meters that are in the height. So we have our final value for y. 6.3020 meters. Okay. So after we have here our y, we're going to calculate our potential energy. That is calculated just as mass times gravity times height. It's going to be 12.35 joules.
Okay, for the second part of the problem, we need to know the change in potential energy between the initial and the maximum height. So we know that our equation for work equals change in potential energy. So it's equal to final potential energy minus initial potential energy. This means that our final potential energy is the potential energy in its maximum height. So we'll use the result we already know, minus substituting initial potential energy by mass times gravity times initial height.
Okay, so we're just going to plug in the numbers. We know that the potential energy, the maximum one, is already 12.35 joules, and we're just going to subtract the initial potential energy, and we already know the data. So we're just going to plug in, instead of just having the letters, we're going to put mass, that is 0.2 kilograms, the force due to gravity, that is 9.8 meters per second squared, the initial height, that is going to be 1.2 meters, and we're just going to go ahead and multiply that, and we're just going to subtract it to our maximum potential energy, giving us a work of 10 joules.
The mirror's image, it tells me you're tongue-tied, but I'm not finished, 'cause you're